Have you ever really truly thought about what it means to see something? I mean, it feels so simple, right? Light bounces off an object, zips into your eye, and bam, you see it. But what if I told you that by the time a single sunbeam actually reaches you, it's already been on this wild, incredible journey? Let's trace its path. It's pretty amazing.
So we're going to follow one ray of sunlight, all the way from the blackness of space through our atmosphere and right to the back of your eyeball. And trust me, it's a journey that's full of twists and turns, literally bending, scattering, and creating these mind-bending optical illusions that fool us every single day.
All right, so the very first challenge our little sunbeam faces isn't on the ground at all. It's the air we're breathing right now. Yeah, Earth's atmosphere is like a giant, invisible obstacle course for light.
You see, as light comes screaming in from the vacuum of space, it hits our atmosphere and suddenly has to travel through all these different layers of air, each with a different density. And that change makes the light bend. We call this atmospheric refraction. A perfect way to picture it? Think about a straw in a glass of water and how it looks bent. It's exactly the same idea, just, on a planetary scale.
Now, this bending has a really surprising effect on our daily lives. It actually gives us about 2 extra minutes of daylight every single day. How cool is that? Because of this atmospheric refraction, we see the sun appear to rise about 2 minutes before it physically clears the horizon. And then at the end of the day, it sticks around for an extra 2 minutes after it has actually set. So yeah, what we call sunrise is basically a beautiful illusion. The light from the sun is literally bending over the curve of the Earth to reach your eyes, even while the sun itself is still hidden from view. Our brains don't account for the bend though. They just assume light travels in a straight line. So your brain just paints a picture of the sun in a place where it isn't even there yet. It's an absolutely brilliant trick of the light.
Okay, so bending is one part of the story, but that's not the only thing the atmosphere does to sunlight. It also scatters it all over the place, and that is the secret behind some of the most beautiful sights we see every single day. So our atmosphere, it's not just empty space, right? It's filled with billions of tiny particles. We're talking dust, little water droplets, molecules of air. When sunlight comes in and smacks into these particles, it doesn't just pass through. Nope, it gets bounced around and shot off in all sorts of new directions. And that is scattering. Now here's the fun part. During the day, blue light, with its shorter wavelength, gets scattered way more easily than all the other colors. So all that scattered blue light fills the sky, which, well, makes it look blue to us. But at sunrise and sunset, it's a different story. The sun is way lower on the horizon, so its light has to travel through a lot more atmosphere to get to you. By the time it arrives, most of that blue light has already been scattered away, leaving behind those gorgeous fiery reds and oranges for us to see.
All right, so our beam of light has made it through the atmosphere. Now it starts to play some really cool tricks on us right down here on the ground.
Now, the secret ingredient behind some of nature's best illusions is a principle called total internal reflection. This happens when light tries to go from something dense, like cool air, into something less dense, like super hot air. If it hits that boundary at just the right angle, it doesn't pass through at all. It just reflects, like it hit a perfect mirror. And this is exactly how a mirage happens. On a really hot day, the air right above the road gets scorching hot, making it way less dense than the cooler air just above it. Light from the blue sky travels down towards the road, hits that layer of hot air, and bam, it reflects right back up into your eye. Your brain, again, assuming light travels in a straight line, just interprets that reflection as coming from a puddle of water on the ground. I am positive we've all seen this. You're driving down the highway on a blazing summer day, and it looks like there are puddles way up ahead. But then as you get closer, they just vanish. That's not magic, that's a mirage created by total internal reflection. Pretty wild, huh? Okay, so our ray of light has bent, it's scattered, it's even reflected its way to you. Now it's time for the final, most important leg of its journey, into the incredible biological machine that is the human eye. So to actually make sense of this light, your eye uses this incredible tool, a lens that isn't made of rigid glass. It's flexible. It can actually change its shape on the fly. And this remarkable ability, called the power of accommodation, is what lets you instantly shift your focus from a bird in the sky to the phone in your hand. And the range here is just staggering. A healthy eye has this amazing depth of field, letting you see things clearly from about 25 centimeters, so the length of a ruler, all the way out to infinity. I mean, think about it, to the stars. It is an absolutely mind-blowing feat of biological engineering.
But you know what happens when this perfectly tuned system isn't so perfect? Well, that's when we need to give it a little bit of help to bring our world back into sharp focus. Sometimes the eye's natural lens just doesn't bend the light to the perfect spot on the retina. So for nearsightedness, what we call myopia, the light focuses a little too early, in front of the retina, which makes things far away look blurry. For farsightedness, or hypermetropia, it's the opposite. The focus point is behind the retina, blurring things up close. And then you've got astigmatism, where an uneven cornea just scatters light so it can't form one single sharp point of focus. But the fix for all of these is beautifully simple. We just give the light a little bit of a head start. Eyeglasses use a precisely shaped lens, concave for nearsightedness, convex for farsightedness, to bend the light just enough before it even reaches your eye. This makes sure it lands perfectly where it's supposed to. It's really just one final, very helpful trick of the light.
So from a sunrise that isn't really there yet to a puddle of water that's actually just the sky, our perception of the world is constantly being shaped and, well, tricked by the physics of light. It really makes you wonder, doesn't it? What you see isn't always what you get, so stay curious.